Okay, so exploratory data analysis, EDS, assumes that you have your data set already, and then you want to explore the data set, right? So exploring the data set means you want to know more about the data set. You want to gain some insights from the data set. So it's not yet time for applying it into any machine learning model, but you want to know what relationship exists among the variables, or how many variables, how many rows, and things like that. There are many things to do when you are carrying out EDS tasks. So as I said, I will just go straight to Google Colab and then show you some few things that you can do as part of exploring a data set. Maybe we can make use of the file that we look at this morning, but it doesn't stop there. As I said, data may come in different format. So, but for the sake of these sections, we might be using CSV file. Which file is this? So don't worry, I will see which file we can use it. Okay. So for the presentation, all right. So maybe you haven't understood what I said before. There is no provision for a presentation slide for this particular section. I have said it right. So that's why there's no presentation slides. Sorry about that. We will just go to some practical things now, and then we call it a day. So let me just share my screen and then see what I'll be able to do. I just come up with some few cells. Let me see if you can see this Google Colab. You can see it, right? You can see this. All right, so look at this. If you want to do data explore, yes, you want to explore a data, you need some packages. Let's say we are using Python to do that. So you have seen yesterday different Python packages when you are doing, let's say, introduction to Python. So for the sake of this, we might not end up using all these packages, but let's say we will import some libraries. Panda is one, and then NumPy is one, and then Seaborn is one. Seaborn is for plotting, and then NumPy is for handling some array, and then Panda is for creating some data frame. Okay, and then here we also assume that we have a file, a data file that is in CSV form, like the one that we used recently. So what we need to do first is to upload the data. When you are using Google Colab, you need to upload the data into the virtual environment. So do we have any data here? Let me upload again this one that we used this morning, the heart. Okay, so and one of the disadvantages of using Google Colab is once I shut down this system, this file goes away. So anytime I come to work on Google Colab, I need to upload the file again. It's on the drawback. So, and then the first thing is to put the data. We are going to use the Panda to read this data. Okay, and so let's supply the name of the data here. What is the name? You need to provide the exact name. So saheart.csv. So SA at CSV. And then after that, we want to view the height of the data. What do you mean by the height? That is the first 5 rows. So let's run this cell and see what happened. Right. So this is what we first. So the first thing you need to do when you want to explore a data is you need to load this data set. You need to visualize the data set. That is to give you what? More importantly, you need to visualize the height of the data set to give you the names of the variables, the input features that are contained in the data set. So for this one, this is the first 5 rows from 0 to 5 or to 4. And then we have this is nothing but rows.names. This is name of the rows, row 1, row 2, and so on and so forth. So we can use this index to access it. And these are the features that we have. SBP, tobacco, LD, and so on. So all of them with some what? With some value. So for this feature, it has a numeric value. This one has a categorical value and so on and so forth. So this is it. And sometimes you want to look at the what? df dot, let's say, tail. So if I comment this, let's say I just want to look at the last 5. You see? So why do I need to? There are different ways. So I look at the tail. That is the last 5 rows in this data set. This gives me an idea of how many data records I have without even, I can do that with Python, but it's one of the way to find out how many data records you have. All right. So you have around 463 data sets. Okay. 463 samples. All right. So this is the first thing to do. And then next thing that I put here is info and then describe. Let me comment this one for now. So you want to know more information about this data set, and then Python has a way of doing that for you. So you just call, there is a function called info. So you see df.info. Why are we using df? That is the variable that we use to assign this data into it. So anytime we say df, we're referring to this data set of sa_hat.csv. So we want to utilize this info function to know more about this data set. So if I run this cell, now what information do we have about this data set? This is it. So it's saying that row names, it has what? It has 463 rows, and then none, there is no non-value, and then it's of type, data type is object. And then for this, and these are the parameters or input variables that we have: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then each of them is telling you the type of data type. So like SBP is a float 64. So anything float 64 is telling us like a numeric value, and then farm his is object, so it's like a categorical value. Okay, and is it a question or what? No problem. I will attend to question last. So this is the information that we have. The data type, whether there are null value or no. If there are null value, it will tell us the count of the null value. That is if there are some missing values. Okay. So let's uncomment this and then, oh dear, sorry. And then what do? We don't need info now. So let's comment info. And then we want to use the dot described. What is this function doing? Is describe, not now we're not only looking for information from this data set, but we want Python to describe some things regarding this data set. And this description normally is a statistical description. Okay, so this is what the describe function does for you. You don't need to start calculating so many things. So it tells you the number of what rows or samples or counts here. And then it tells you the mean for this parameter, the standard deviation, the minimum value, the 25th, 50th, and 75, what do you call it? Is it quartile? And then the maximum value as well. So this is what the describe function does for us. So it's describing the function, what? Using some statistical tools, like the things like that. And then actually, I want to find out if there are some duplicates in this data set. Find the duplicate. So this cell and then zeros. So if it says 0, which means there are nodes in this set. But if there are duplicates, we'll see. Sorry, I think my network was fluctuating. Can you hear me now? My network was a bit bad shortly. I hope you can hear me. Thank you, Alistair. All right, so let's proceed. So what we need to do is we take one of these, let's say SBP, and then this here, and then let's try three futures. Tobacco, and then put it here, and then let's say which one is next. LDL, and then put it here. So let's run this cell and see what happens. All right, we've got a row here. So series object has no attribute unique. Oh, all right. There is a typing hero, I think. Okay. Okay. You right. This here unique. All right. Let's run it again. Okay. So it has gone down. So look at it. A lot of things here. Unique. These are what we have got as unique values for these particular futures, SBP, tobacco, and LDA. And this might not make sense for you, I think, for now. But the next thing is to find null values. Find null values. Rows dot is 0. So tobacco 1, this 1, and so on and so forth. We have seen the data types already. This float. All right. What I want to run is to run a correlation. Let me see if, all right. There's one of the things that you will normally come across to do is a correlation. You want to correlate, you want to carry out a correlation on the futures. And then this is the table that is generated for the correlation. And you want to see the correlation value is either positive or negative. I think that's what I want to explain. And if a correlation value, if two variables are their correlation value is positive, it's saying that these two values have a strong relationship. They might have a greater influence to any output variable if they are used as input variable. Okay, so most of the time, and then the highest value for the correlation is 1, and value is always minus minus. So if you have two variables that have a correlation value of 1, which means they have a strong relationship between them or among themselves. There are what we call Pearson correlation and so on and so forth. You might want to try with some of them. So if you look at this, you see tobacco, let's say start with SPP, and SPP is already 1 because it's just we are correlating this variable to itself, which is normally it will give us the highest value. But we want to see what is the correlation value for a particular variable when it's been compared to another. So like tobacco and SBP, it has where the intersection tells you what the value is found where these two variables intersects. So tobacco and SBP has a correlation of 0.2. So it's a positive correlation, even though it's not a high value. High value is like from 5 upwards. So, but it's a positive correlation, tells us that they may have a positive influence on any output variable. All right. But when you look at here, the same tobacco with type A, it has a negative correlation of minus 0.0111, which means if these two variables are used, let's say to predict something or to predict age or anything like that, they may have a negative effect or negative influence on the output variable, and so on and so forth. So there are a lot of values here. I just picked two to explain. So you can find out which two variables has the highest positive correlation value. I think from what I can see, if my eyes are not lying, it's like this one, 0.388, that is age and SBP. They have the highest correlation value. No. Oh, yeah, school and school is 1. Yeah. So like age, SBP has the highest positive correlation value. And then you can find out which combination of features has the lowest or the highest negative correlation value. So, yeah. Okay, thank you. I'm having some, I think, network problems. So it's showing now, Adam. All right. So we're just trying to explore, as I said, one of the major tasks that you will come across when you're doing EDS, exploratory data analysis, is correlation. You need to perform some correlation to see what relationship exists among the features or among the variables. From here, you will even know which features will contribute positively on the output and which will not contribute. So for this one, we have used this data set for binary classification. So, and then if you compare this with what we have, can I still have access to this data set, the collab that we use? Ensemble, okay. Data importance. Right, so what are we saying? Look at age. I say age and SBP are what are, from this correlation, what is this telling you? They have the highest positive correlations, So, which means these features, they may have the highest future importance. I'm just trying to confirm. So if you look at what we did in the morning, look at this is a future importance that was generated from which of the model? Is it random forest or decision tree? No problem. But look at it. tells you the contribution, the future contribution of each model on the output. So look at H. H has the highest future importance. Okay, so even before you come to this, when you perform EDS, you should be able to know which future. So from here, we are just doing EDS. We did not even use any model. And then now we discover that H, because of the correlation value, it might have a positive or greater future importance on any model that we develop, and then we have confirmed it with what we have done so far. All right, so look at what H, the value for H. So when you do EDS, exploratory data analysis, and you use the right tools to do it, you will have so many information. You have a kind of insight on the data set even before you start building any model, before you start using the data set to perform any machine learning tasks, either classification, regression, and so on and so forth. This is not the end. There are a lot of things that you can do as part of EDS, explanatory data analysis. I just show you just some few of them, and then one of the important thing that you will do is the correlation. You need to correlate the futures to see what information you can gain, but you need to have understanding of what correlation is before you can do. And then if you are interested only in the statistical information of the data, you can call the described function. If you are only interested in the information, you can do that, missing values, and so on and so forth. So EDS is part of what you will be doing when you start your program proper. And most of the time you do EDS in what we call pre-processing activities, data pre-processing activities. So you are carrying out some pre-processing activities on your data set even before you start feeding the data into the machine learning. So you want to explore the data, you want to see what. So most of the time, sometimes, so for instance, now from here, what information, what important information do we have? This correlation will tell us which of the variables they might even have negative influence on the model output. So like the ones that with the negative values, so we will decide to take them away even before we start feeding them into the machine learning model. So we can decide to make use of 2 or 3 features here if really they can work fine at the end of the day. So these are some of the things that you might think of, not only carrying out the EDS, what is what information or what will you do with the result at the end. So the EDS will help you. One of the things is it will help you to know the important features that might contribute towards improving the machine learning model performance, and it will help you also to know which features you will get rid of them because they might end up frustrating the effort or your effort in achieving higher accuracy and also improving the performance of your model. All right, so this is just one of them, and I would like to stop here. I don't know if you have some questions and then you can ask, then I will attempt to them. And if there are no questions, I would like to draw the curtain at this point and then wish you the best for the rest of the day and also for your hackathon tomorrow and also your program when you start proper by next month, September. So as I said, this is just a brief and then just a foretaste of EDS. There are a lot of things that you can do when you carry out EDS. All right, can you please clarify what future importance mean? All right, so let me come back here. Future importance, share screen again. So look at what we've done before. This is just a plot from, let me see, the last model that we did, random forest model. So we have developed a random forest model here, and then the random forest model, we have calculated the training accuracy and the test accuracy. It has a 0.97 training accuracy and then 0.71 testing accuracy. And then we plot the future importance. What do you mean by future importance is The left axis is the features that we use as input variables. So this model accepts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 features as inputs. Make use of the values of these features to predict or to classify. Okay, so this is telling us the this is the this is y-axis. So on the y-axis we have the number of features, and then on the x-axis we have values here, so telling us the influence of each feature on the model prediction. Influence or positive influence, all of them has a positive influence, but you see age has almost 0.14. So this tells us that this variable age, okay, has a positive influence on the output of the model. Influence the output of the model. Okay, it's one of the important features. And then followed by, which one is next? We have row names. So what is telling us here is if you take away this feature, you remove this feature from the input model inputs, then your accuracy will drop down significantly. Or let's say, for instance, you don't want to make use because we are looking for what is the importance of all these things. So for instance, if you are not interested in using these 10 features, let's say you want to use only 5 features. So this plot will help you to select the right features that you will have a good result at the end. And then what you need to do is to select the features that has the highest value of future importance. So you will start selecting age, and you will select obesity, you select LDL, you'll select tobacco, and then you will select row name. So these 5 features will perform well. All right. So this is just brief about what we mean by future importance, and then I hope it helps you. Is it Afyong? Will you be able to share this file with us? It seems like it will be useful for the hackathon. Okay, is it the one that I just created for the EDS? Alistair? All right, so I just created this one during the short time of break that we had because there is no provision. I will do so. If you can see it, I just created it in Jupyter. I did not even title it. Okay, so I will title it as EDS, and then so let me just download it so you can. Let me just download it and share it with you as in Jupyter Notebook. All right, download as Jupyter Notebook. All right, so where do you want me to share it with you? I don't know. Some of you, do you have access? Should I put it here in the chat box? Is that okay? Can you download it from here? I don't have any link to share with you here. Let me stop sharing. They don't give me access to share file here. I'm not sure. Oh dear. Formats. Do you have access to the folders in SharePoint? With the tree folder? Yes, share drive link. Okay, I will put it in day 3 in the OneDrive day 3 folder. Okay, I will put it there, please. You will find it there. So you will see it. I name it EDS dot what is it? Is it P? Let me double check the name. All right, IPY notebook. Okay. On module, I'm not sure. if it is on module. NB. This is the name of the file. You will find it in the tree folder, please. I think you have access to the tree folder, Rosalie. Don't you? Some of you have access to all these folders. Even day 4, tomorrow day 4, you will be doing your hackathon. I think you must have, if you don't have access to the folders, how will you do the hackathon? Okay, I will find, I don't know where to find them. Please, I will confirm with Mariam, please. I will find out from Mariam because are they supposed to give you access to these materials? Let me stop recording. Yeah.